Right, this is the video for difference of squares and factoring cubic polynomials. So before you started this video, you should have done the two multiplications at the top. If not, pause the video and do it now. So looking at difference of squares is when we have a binomial where we've already factored out a GCF, where we have two perfect squares separated by a minus sign. So if we look at this formula, a squared minus b squared equals a minus b, a plus b. So a is obviously the square root of a squared, and b is the square root of b squared. So if we look at our first example, we have two perfect squares separated by a minus, so this qualifies for a difference of squares, a little shortcut. So if we make our double bubble, we take the square root of the first term. So the square root of n squared is just going to be n. So that's our first term in both of our parentheses. Then, if we look at the formula, always opposite signs, plus minus. It doesn't matter which one goes first or second. And then we take the square root of that second term. Square root of 64 is 8, so that's going to be the second term in both of the parenthesis sets. That's it. You can always FOIL it back out to double check. In our second example, same thing, there's no GCF, so we can go right to our difference of squares formula. If we take the square root of 4m squared, we have to be careful because we have a coefficient that's a perfect square and the variable is a perfect square. So the square root of 4 is 2, and then the square root of m squared is m. Opposite signs, and then we're going to do the same thing for 81n squared. The square root of 81 is 9, and the square root of n squared is n. Final answer. Sometimes we might need to take out a GCF before we can see the difference of two squares. So if we look at this problem, I know that 2a to the third power and 98ab squared, neither of those are perfect squares. However, if I take out my GCF of 2a, then I'm going to see something happen. So I've got a squared minus 49b squared in parentheses now after I took out my GCF, which is difference of squares. So again, we can write our double bubble, and we're going to take the square root of both terms. The square root of a squared is a, opposite signs. Square root of 49 is 7, and the square root of b squared is b. There's our final answer. Don't forget to keep the 2a on the outside. Go ahead and do the 2 u tries at the bottom. The next thing we're going to look at is factoring cubic polynomials. So with cubic polynomials, we have 4 terms starting with the cubic term. So we can plug those right into the box method for factoring. First term, second term, third term, last term. And then we can follow the same process as the box method factoring, where we take the GCF out of each row and column. So I'm going to go ahead and move through this a little quickly because we've done this before. And I get two binomials, x squared minus 9 and x minus 8. So when I write them next to each other, we have to be careful, and this says it above, because we can factor the remaining quadratic, DOS difference of squares. So this was earlier in the video. So x squared and 9, both perfect squares separated by a subtraction sign. So we can make our double bubble, and don't forget to bring down that x, oops, that should have been an x minus 8, not an x plus 8. And then we're going to take the square root of x squared, which is x, opposite signs, and then the square root of 9, which is 3. There's our final answer. We'll try one more together. So the next example, again, 4 terms, we can go right in order, plug them in. Factor out the GCF to the left, factor out the GCF to the top, and then we get two binomials. One is quadratic, but 3 is not a perfect square, and we don't have a subtraction sign. There also is no GCF, so that is a prime quadratic. We can't factor it, so we're just going to leave it. So our final answer, x squared plus 3, 2x plus 7. Go ahead and do the u-try, and don't forget, if you get a difference of squares as one of your binomials, you need to fully factor it.